So yeah, we're focusing in on unit testing, and we had a little bit of experience of that in the lab, albeit what we were testing was pretty straightforward, arguably, but you got to start somewhere. And secondly, we were using what I'm calling, or what's often referred to as, just a custom script as our automated test. And that script, even though we had only, was it 4 methods to test? It was still quite long, and not so much that, but it was a very linear kind of coding experience. And you had to be careful that one test didn't impact on another test. There was no easy way of isolating each test from the other test, which is really what you would like to ensure. You kind of had to manage that yourself. So there was lots of weaknesses using the custom approach. And that's really why we have testing frameworks to put a structure, force a structure on our testing code, and also to get some extra benefits, which I'll mention as we start talking about one particular framework. We also saw the last day about this idea of using the given, when, then as a way initially, or as a way of identifying the different test cases. Now, arguably, it wasn't really necessary because our methods were pretty straightforward, but it's as much about identifying the different test cases as it is about documenting the different test cases. And by documenting, you remember we did a console.log of each given, when, then for each of our test cases in our script. That would be beneficial to other people that might be assessing our automated tests. So they could look at, when they ran our tests, they could look at the various given, when, then statements that were being outputted, and that would allow them to make a quick assessment as to whether your automated tests were complete or not. So it's very much, it's as much for somebody else reading your test cases as it is for you designing your test cases. It serves both purposes, but don't forget about other people actually reading your tests and making sure that they're happy that your tests are complete without having to actually read through the testing code. All they really want to know is look at the output and is this test sufficient or not? So that was that. So we have talked about the deficiencies in the automated testing, custom automated testing. Hence, we have these testing frameworks. Every language has them. In the case of JavaScript, the most popular one is Mocha. There are lots of them though. And if you did look at a testing framework for another language, my guess is you would find that some of the ideas that you find in Mocha, you find in these other frameworks as well, these other testing frameworks for other languages as well. So that's kind of nice. You can transfer whatever you've learned under Mocha to other testing environments. And with Mocha, so what I said there a moment ago is that these testing frameworks, and Mocha is what we're talking about now, it actually forces you to structure your testing code. And the structures are built around what are called describe blocks. And within a describe block, we have it blocks. So these are the 2 main constructs that we use to structure our code. And we also have what are called before and after hooks. And just from a syntactic point of view, you can have nesting of describe blocks. You can have describe blocks within describe blocks. And this again is all about structuring your code. And you would have, typically you would have more than one it block within a describe block, whether that describe block is deeply nested within other describe blocks or not. That tends to be the way that it works. And you tend to have before and after hooks at the beginning of a describe block. So you finish up with something that's structured like this. And this is kind of where we got to the last day. In fact, you know what I could do is if I flip over to VS Code, because we have this catalog, this product catalog little use case in our minds. So if I show you the mock-it test equivalent of what you wrote the last day, that will give you a sense of what I'm talking about here now. And really, this is what you're going to be doing in next week's lab anyway. So this is kind of a preview of it. I've got it here. So again, our source consists of, well, forget about those two. We have product and we've got product catalog. And this is what we saw the last day. It has more methods though, but we recognize those methods there from the last day. And in my test folder, I've got this file here, and here is my mock-it test code. So I've got an outer describe block. Typically what I'm testing now is the product catalog. I've got a before block where I seem to be initializing my catalog and putting some products into it. Typically in the before block is where we put setup code, and that this is sensible setup for our catalog class. I've got an inner describe block, and you can see my inner describe block. It looks like the inner describe blocks are at the kind of method level. So this describe block here begins here and it ends here. Here's another inner describe block, which is focused on this method, begins here and ends here, and so on. And within this describe block here, I've got two it blocks, and you can see the method that I'm testing is the find product by ID. There are really only two test cases: when you give it a valid ID and when you give it an invalid ID. So presumably this one is checking for when you give it a valid ID as the text, and this one is the invalid case. So that's kind of a that's really what you're going to be producing the next day in the lab, but just to give you a sense of it. Now, you can have any degree of nesting of describe blocks that you want to. So for example, if the particular method that you were testing had, let's say, I don't know, 15 different test cases, may arise, then having 15 it blocks listed linearly might not be great. Maybe those 15 different test cases could be broken up into, let's say, 3 different subgroups. Well, what would be nice is that you would have inner describe blocks for each of those subgroups. So it's really up to you as to how much nesting of the describe blocks you do. And it's kind of based on the scale of the thing that you're testing and also your own level of organization, I suppose, really. The syntax then looks a little bit clumsy and complicated initially, but you get into the hang of it. By that I mean the describe block takes 2 arguments. It takes a string and it takes a function. This is a function beginning there and ending there. The string is meant to express the context of the describe block. In other words, what are you testing within this describe block? This is telling us that it's testing the catalog class, whereas this describe block is telling us that it's testing a particular method within that class. And these things don't have to match. Like that does not have to match the actual method name. You could write it in a more English-like way if you want to. And then it's just from the syntax, you know, the second argument has to be a function. You don't have any leeway on that. So you just take it. But within the body of that function, then you either put an it block, or as we see up here, you have a before block. You'll get into the swing of it, I think, once you have practiced it in the lab. So that just gives you a sense of the structure of the code. I'm harping back to the given when then again here for you, just to give you a sense, because that core kind of principle still applies. So we tend to put the given part of our given when then in the before each block. What I should say actually as well, I documented somewhere in the slides, is the way it works is when you run this test, clearly it's going to run each of the it blocks. Maybe if I go back to VS Code. When I run this overall test, it's going to run each it block, because each it block is a separate test case. But before it runs each it block, it will run the before each block. But another way, the before each block of code is executed before each it block, is executed. And what's the idea behind that? The idea is that you reinitialize the context for each test case. Each test case is now completely independent of every other test case, because we are essentially kind of resetting our context every time. And so each test case, each of these it blocks wraps one test case. Each test case is completely isolated from every other test case. And we like that as a principle. So I think everything that I say there now is mentioned in the text of this slide. So you can go back and look at that for yourselves. I'll just pause for a second, maybe in case people have any questions initially anyway. So you probably have to practice in the labs, but I'll give you an opportunity. No? Okay. Terminology, there's always terminology. We talk in testing, we talk about the target. So the target is that piece of the application that a test is examining. So in the case of the file that I just showed you there a moment ago, the target was the catalog class, and each it block had a target of a particular method within that class. So the target is that part of the application that is being tested. A unit test, I'm saying, which we probably know by now, a unit test is a group of tests for a single unit. Typically, a unit is a class, if classes are a construct that makes sense in the language that you're using. They do in JavaScript and Java, obviously. You may write a lot of JavaScript that doesn't use classes at all. It only uses functions. So arguably the unit in that case would be a function. So it's a flexible kind of concept really. A unit is whatever you want it to be that makes sense in the context of the application that you're testing. So you've got a unit test for each unit, and then a set of each unit test is comprised of test cases. So that would correspond to each it block really in the case of Mocha. And as we know, kind of a test case would relate to one particular given when then scenario for your target. We're going to have lots of units in our application. So a collection of units, I'm saying, is a test suite. Doesn't arise in our case because we only have one class that we're testing, the product catalog. But if we had other significant classes, we'd have unit tests for each of those, and the collection of all of those unit tests we just refer to as a test suite. Some principles. I'm saying number one, each test case should be executed independently. Where's my arrow gone? Each test case should be executed independently of other test cases. And I was harping on about that when I was talking about the role of the before each block. You can also have what's called an after block. An after block is executed after each it block. So maybe in an after block, you would do some cleanup code to ensure that everything was reset back to where it should be, whatever that means. If you're testing something that talks to a database, maybe after each test case, you just want to flush out the database or whatever. But this concept of independence is very important between each test case, not between each unit test now, but it's down to the level of each test case within a unit test. Now, this is one that can catch people, or does seem to catch people initially anyway. I'm saying that the test target state as well as the response needs to be tested. Now, in the test that we wrote the last day in the lab, we were only concerned with testing the response that was returned back by whatever the target method was. But if the target method makes some internal state change, then we would need to ensure that that has happened as well. Now, I give you a simple example of what I mean by that. And it is a trivial example, but still it serves the point of what I mean by testing the target state. If we look at actually what I'll do, I'll go back and I want to undo that. I'll bring in my solution from this week's lab, which is here. No, it's not. Here it is. And if we look at the remove product, this one here. So what I would say, even though it is a trivial method now, what I would say about this method here is it carries out a state change to the product catalog object itself. And the state change is happening here in that it is actually making a change to this part of a catalog's state. State means its internal data. A catalog object has two parts to its internal state, the title and the array of products. And some methods will make a change to the state. And when you're testing those particular methods, you should ensure that it does actually change the state, as well as returning the right response. You should also ensure it makes the appropriate state change. So when I gave you the specification for the remove product by ID, I said that it returns a true if it removed the product and it returns a false otherwise. And the reason it might return a false is it couldn't find the product that you asked it to remove. So that's my specification. There's my implementation, which works, obviously. Here's my test. At the very bottom. And there are no surprises here either. Okay, but all I'm doing in the test is, so I'm calling it with a valid ID, and in my test, I'm checking the response that comes back. If it's true or false, then that determines whether my test passed or failed. But I never actually prove that it did actually remove the product from the catalog. And so if I did something silly, so if I run these tests, presumably they're going to pass. everything passes. We're only interested in the remove product for now anyway. That's the only one we're concerned with. So it looks like they all passed, which is great. But if I did something silly like this, now by commenting this out, I am not making the state change that I should be making based on the specification. But still, when I run my test, it's still passing. So clearly something is wrong. My test is insufficient, or I haven't implemented the method right. It should not be passing in this case. Now the reason, so what I really need to do is, let's assume that, and just bear with me now, let's assume that I leave my implementation like this. So all of this code is gone. Then how would I prove that my remove product method is actually not working? What should I do in my test, I wonder, to check that it did make the necessary state change? What I could do is here, after I've removed the product, and if the remove worked properly, then if I try and find that product, the find should return whatever the find method returns when it cannot find a product. So I need to put some extra code in here that calls the find product by ID and then examines the response that comes back from that method. And I know, I think based on the specification, I said if the find product by ID returns undefined, that means it could not find the product. And that is what I would expect find product by ID to return if I invoked it in here. And so I'd have an if test stating if the response was undefined, then the overall test passed. So the principle is just be aware of your target. And if the target method in this case is meant, based on the specification, to carry out some state change, then you need to include in your tests an expectation that examines that it did actually carry out state change. Jumping around a little bit now, but if I now go back to, if I go back to the other one, just want to undo what I did here. Maybe I won't. This. Here is my mock-up test for the remove. And here's the test when I give it a valid ID. And you can see here, based on the comment, I'm also checking to make sure that it did actually remove the product. So I am calling find product by ID and giving it the ID that I hope has been removed. Now you won't understand this line of code, but the effect of this line of code is to check that result in this case is actually equal to the value undefined, which is what it should be if my remove product by ID has been implemented correctly. So that's principle number 2. And principle number 3 is what we call the silent principle. You know, when we ran our tests using the custom script, we had loads of console.logs, and really all we really want to know is, did everything pass? If something did not pass, I just want to know about that one. I don't want too much output coming back at me. I want the bare essential knowledge. So when you are writing tests using a framework now, then make sure you don't have any unnecessary console output to the tester. You may need to use console output when you're doing debugging, but just make sure you remove it after you finish your debugging. The last principle, have informative test case documentation. Now, the way we documented our tests when we were using the custom script is we had console.logs of the given, when, then kind of sentences. That's what I mean by test case documentation. Hopefully, Mocha allows us to do that as well. And that's really what the purpose of, if I go back for a second, that's what the purpose of these strings serve in the case of Mocha. You've got to think about what you express inside in these so that it's clear to other people that are running your tests as to what you are testing. So there are principles, and we'll experience those hopefully in the lab the next day. There's always the question of, well, how much testing do I need to know, or when do I know when I can stop testing a particular target? And I'm trying to give you an indication here as to how to answer that question. And I did mention this in the lab the last day in passing. So whatever is the target that you're testing, and let's say for the sake of argument, we're testing some target method, then think in terms of these three different kind of scenarios. The normal scenario, by normal we mean that the target, you're passing it normal parameters. The parameter values are something that's commonly occurring. And also that the target's initial state is something normal. In the case of the product catalog, you know, normal would be there are some products in the actual catalog. That's fine. Most people would, when they're writing their test cases, would cover the normal cases. Then the second group of test cases that you need to be aware of are what I'm calling error cases. And this is really focusing in on any exception handling that you should have in your target method. If you have exception handling code, then you need to test that that exception handling code is working when it should be working. And that usually results from maybe passing invalid parameters to the method, or the state of the target or catalog in this case is in error, whatever that means in the context of the target. But you do need to be, if you have, as I said, if you have error handling code in your implementation, clearly you need to test that that error handling code works when it should work, and conversely does not throw exceptions when it shouldn't throw exceptions. The error handling may also emerge from the actual requirement specification for the method. The third case then is the one that I alluded to as well the last day, this idea of boundary or edge or corner cases. Where it can arise is if you've got a particular parameter for your target method and you're told in the specification for that method that a particular parameter, its value has to be, let's say, within an upper and lower bound, then you need to test that the method is behaving properly when you give it a value for that parameter that is just on the upper limit and just on the lower limit. The specification should tell us what should happen in those cases. So we need to test that our method responds appropriately when a particular parameter value is on a boundary value. In some cases, it may not apply, you know. Now, if we just take the simple example of the product catalog, we had a find product by ID method. We're just going back to error for a second. We have find product by ID method. Now, an error case in the case of that method is not when you give it an invalid ID. That would actually be a normal case. We didn't have any exception handling in our find product by ID method. But back to boundary again. So you just need to have an awareness of this notion of boundary cases. As I mentioned the last day, most people will write their normal test cases. Most people will write their error test cases because they realize there is error handling code, so they'll write tests for it. What a lot of people miss out on is testing the boundary aspects of your target method. And as I said the last day, most applications work fine under normal circumstances, but it's when you start hitting it with abnormal, i.e. boundary or edge cases, that's when applications crash or fail. And the reason they do that is because they haven't been tested around these boundary cases. So you need to keep those three different possibilities in your mind when you're doing unit testing. And if you tick each of these boxes, then at that stage you could answer, yes, I have done enough testing now, I can move on to whatever your next task is. Now, so Mocha is the framework that we use for structuring our unit tests. There's a separate library called the Chai, at least that's how I pronounce it, the Chai library. And this library is used to allow us to express the expectations in our testing code in a more expressive way, I suppose I put it like that. So it's a separate library that you use with Mocha. You can use it with other unit testing frameworks as well, JavaScript now. And what it is it enables us to write what I'm calling a fluent coding style for expressing expectations. Remember, expectations is what you expect. It's a way of stating what you expect the response from the target method to be, or, as we know now, what you expect the state of the target object to be after your target method has executed. So either way, it's a way of expressing these expectations. And I have an almost full list of all the different types of statements that you can make using this Chai library for expressing expectations. And initially it looks a little bit complex to write, but if I go on to the next slide, here are some actual examples. So this is, believe it or not, just normal JavaScript code, but you could almost read it like English. So this seems to be saying, I expect the result variable, so presumably the result is a variable that you assigned to the response that was returned back by your target method. You expect the result variable to equal this string. So maybe the particular method, whatever it was, is meant to return, let's say, a product name as a string. And you assigned that, whatever it returned back, you assigned it to this variable called result. And this entire statement now is stating what I expect that result variable to contain. So it's, as I said, it's English-like and it's expressive, and it's a way of coding our expectations. Here's another example. I expect the result to be null, to be the value null. So that might arise. I expect result, it looks like result in this case might be an array of strings, let's say. So I expect the result to have the member that and that. Like if we didn't have this Chai library, how am I going to code this type of expression, this expectation using JavaScript? I'm just going to have to use an if statement. I'm going to have to say if result subscript 0 equals product 5, or result subscript 1 equals product 5. So it's going to be a very long-winded condition statement inside an if expression, I guess. So the child library allows us to express those expectations in a slightly more elegant way than using if statements with very long-winded conditional statements buried within them. That's really the point here. So these are all examples of expectation statements written using the child library. And if I go back to the previous slide, there's lots of flexibility really available to you from the child library. And you'll see that in the lab. And again, if I flip back to the code, here are my expectation statements. So, you know, when I call the remove product by ID, it returns the result. Now, if you remember from the specification, the product by ID method is meant to return a true or a false, depending on whether it worked or not. And here's my expectation statement expressing that I expect results to equal, is that right? Remove product, I must have changed the specification actually. I must have changed the specification of remove product by ID, because this looks like it's expecting the remove product by ID to return the ID of the product that it removed rather than true or false. So the way I would actually, if I was to be consistent with the specification I gave you the last day, I would rewrite this to say to be dot true. It takes a little while to get into writing these expectation statements syntactically correctly. But anyway, that's how I would express the expectation for remove product by ID based on the specification that I gave you the last day. Down here, it would be, that's still okay, I think, actually. So that's the child library, and it's really only by using it and experiencing it that you get into the swing of using it. Finally, test-driven development, which I've mentioned last week to you. It's this idea that you try and write your tests before you actually write your implementation of your target. And we tried it in the lab, and it's not straightforward, arguably, but it's a discipline, and many software houses use it. Here's, in this diagram, I'm describing the kind of process that you go through. So let's assume that our starting point is, I have a specification for a method. And let's assume, you know, it's a fairly involved method now. So that's my starting point. The first thing that you do is you write a test for one particular aspect of the specification. You just focus in on one particular aspect of the target method specification. And you say, I want to see if my method will pass one particular use case. So you write the test for that. Then you actually, you make sure that your test is syntactically clean. That's what I mean by compile here. This diagram is for a generic case. You fix any compilation errors in the test. I haven't written any source code for my target at all yet. I run my tests. Obviously, the test is going to fail because I don't have an implementation of my target method. Now, here's the important point. Now you write your target method, but you only implement that part of the target method that the particular test case that you wrote is concerned with. And I said that you write a test case for one particular part of the requirement specification. And so you only implement enough, just enough of the target method to satisfy that particular aspect of the specification. And having written that, hopefully now when I run my tests, it passes. And if it doesn't, you resolve it, obviously. Eventually, you now have a test that is passing, and you've implemented one part of the target method. If you want to, what you can then do is maybe improve the implementation that you have so far. You don't add any additional capability to the target method. You just refactor it. You improve the quality of the code. And having improved the quality of the code, and that usually probably means restructuring the code a little bit, make sure you run your tests again so that you haven't broken your target method. So we're back up to here. The next thing we do is we take another aspect of the specification and we write a test for that aspect of the specification. We go through the same process down here. We're now at this stage. We now need to extend our target method so that it satisfies the two test cases that we now have. Having done that, we run all of our tests. You don't just run the test, the new test that you've written. You run all of your tests so that everything is still working. Maybe do some refactoring if you need to. And you keep on going through this cycle until eventually you have now written tests for every aspect of the specification of your target method, and you have implemented the method in its entirety. But we're always writing the test first before we write the application code. That's the first principle. And the second one is you kind of take it one aspect of the specification at a time. Don't try and write a number of tests and then write a number of implementations of features in your target. Try and do it, discipline yourself to do it kind of one at a time. And identifying the order in which you should implement particular test cases, that can be a skill as well. So that's the idea behind it. There are some of the key points that I've talked my way through. As I said, he had a go at it the last day in the lab. He didn't necessarily follow this approach, but in next week's lab, I do try and force you to go through this cycle for one method that I give you, and I show you the steps, the number of iterations that you should go through. And then I give you a specification for another method, and it's up to you to come up with the iterations that are appropriate for the specification that I give you. So that's all for next week. And that's really all I want to cover in relation to unit testing. We are not in any way finished with testing. I'm going to come back to the topic at least on 2 other occasions during this module. But for now, that unit testing kind of covered. And if I just flip back to the Moodle site, so here's automated testing that we're talking our way through. The next topic I want to talk about is version control, which means looking at the Git tool. My sense is that some of you have, not all of you have used Git. So the first set of slides that I go through will probably be a refresher if you're already familiar with Git, but we'll dig a little deeper into the Git environment to get a deeper understanding of how it actually works. And we'll also explore other aspects of the tool from a developer's point of view and how it can help the whole agile development process. I was hoping to get onto these today actually, but that didn't arise. That's okay.